Hello and welcome to this brief explanation of present value. The value of money is affected by time. £1 today is worth more than £1 in a year's time because you could have earned some interest by then. Let's use an example to illustrate this. Assume that you can earn 10% on your money and that you are offered £100 now or £110 in a year's time. If you take the £100 now and invest it, then over the year you gain 10% of £100, which is £10. So after a year you would have £110, which was the alternative offer. This means that both offers were of equal value. £100 is called the present value of the £110 future cash flow. Now we could have calculated the £110 value as £100 times 1.10, which basically adds 10%. So to work out the present value, we can take the 110 and divide it by 1.10 to get the £100. And this is known, this business of dividing by 1.10 is known as discounting. And the £100 may be called the discounted value of the £110 future cash flow. So discounting reduces the value of future cash flows to take account of the time value of money. This is also known as discounted cash flow. Now you're quite likely to come across discounted cash flows because they are widely used when evaluating cash flows over time. Right, let's assume now that you invested your £100 for 2 years. As we know, after 1 year it will have become £110. After 2 years you get 10% interest again, and that takes it up to £121, which is basically £100 times 1.10 squared. So if we want the present value of that £121 in 2 years' time, we divide by 1.10 squared to get the £100 present value. So in general terms, this can be represented like this. You take the cash flow and you divide it by 1 plus r to the power of t, where r is the discount rate and t is the number of years in the future. So in the example we just looked at, r was 10% or 0.1 and t was 2 years. Right, let's look at a slightly more comprehensive example. Assume a business buys a new machine for £100,000 and it generates the increased cash flows shown in the table. And we're going to assume that a discount of 10% is appropriate. So there are the cash flows again, and I've put in the discounting. So 10% becomes 1.10, 1.10 squared, 1.10 cubed. And if you take the cash flows and divide by those numbers, then you get the present value, which is shown at the bottom of the table. If we add all those present values up, it comes to £130,165. Now the cash flows in the table do not include the investment of £100,000, so we need to subtract that, and that leaves us with £30,165, meaning the project has effectively increased the wealth in the business by £30,165. A couple of points to note here. One is that the calculation we've done here assumes that the cash flows occur at the end of each year, and you should be aware that you could present this in a different way, which actually does include the initial investment in the table. Right, you may come across the term net present value, or NPV, and this is usually defined as the present value of future net cash flows less the original investment. So in the example above, that increase in wealth of £30,165 is also known as the net present value. Now, a couple of other points. The discount rate. It is difficult to establish appropriate discount rates for businesses. They may be based on their cost of capital or the rate at which they can borrow or invest money, and they may also take account of risk and policy decisions. And we also need to consider inflation. The discount rates I've just discussed are known as monetary rates. Now, these are appropriate if the cash flow forecasts include allowances for inflation, which the one we've just done did include that. If you have forecasts that ignore inflation, then you should use a real rate for discounting, and this will be smaller than the monetary rate. And that's pretty much all we need to do about present values. If you would like more information about any of this, please follow the link on the next slide. Thank you for your attention.